Hello everyone. On this video we will be going over inverse functions. Okay, so before we get started we are going to review the definition of just a regular function. Okay, so remember functions are defined when each input or your x value has exactly, okay, that's the key there, exactly one output. Or y value. Okay, so let's say, for example, if this is your input, let's say this is your output. Let's say you have 1, 2, 3, 4, and you have A, B, C, and D. Let's say if 1 goes to A, say 2 goes to B. Let's say if 3 also goes to B, and 4 goes to C. Okay, this is actually a function. This is a function since every x value or input has one y value or output. Okay, you see the input here has only one. The input number 2 has one output. The input number 3, even though the output for 2 and 3 are both the same, it's still just one output for each input. Okay. Now, with an inverse function, you're actually going in the opposite direction. Okay, so inverse functions are opposite since every output or y value has exactly one input. Or x value. Okay, so here you have the input going to the output. For an inverse function, you're going to have the output going the other way. So you're going to go, instead of left to right, you're going to go from right to left for the inverse function. Okay, so let's give you a quick example. Okay, so let's say, and we'll make these two underneath it. Okay, so this is our input, output. Let's say 1, 2, 3, 4. Let's say this is A, B, and C. And each arrow, that's your f of x. Okay, let's say 1 goes to A, 2 goes to A, 3 goes to B, and 4 goes to C. Alright, so each of these arrows is a function. So you have f of 1 is equal to A. F of 2 is equal to A. F of 3 is equal to B. And f of 4 is equal to C. Now, if you take those very same components, and your A, B, and your C, and this is your input, and this is your output. Let me kind of block this off a little bit. And you get those arrows, and you just reverse them. Okay, so A is going to go to 1. A is also going to go to 2. B is going to go to 3. And C is going to go to 4. Okay, now as soon as you reverse them going from the output back to the input, that's your inverse function. Okay, so when you're going from input to output, that's your function. When you're going from output to input, it's your inverse function. Or in other words, you're going from x to y, that's a function. But if you're going from y to x, that's your inverse. Okay, so if we wanted to write this out, f inverse of A equals 1. F inverse of A equals 2. F inverse of B equals 3. And F inverse of C equals 4. Okay, now if you look closely at this one, this is actually not an inverse function. Even though it's a function, it's not an inverse function. Because if you notice, each y value has more than one x. So your y value of A has more than one x. So technically, this is inverse function. Next, f inverse of A has 2 input values. All right, so this was just to kind of give you an idea of how you would go about creating an inverse function. All right, so if you're still writing, feel free to press pause, but we're going to go ahead and go to our next example. Let's say, for example, if you have that here, you have your input and your output. Okay, so let's say if you have red, blue, and green, you have 1, 2, and 3. Let's say red goes to 2, blue goes to 1, and green goes to 3. Okay, now the one thing we know is that since it's going from your input to your output, each input, or x, has exactly one output. So you have one arrow going out of each input. So we know it's a function. is a function since every input has exactly one output. Okay, so we know it is a function. Now we can also tell that it's an inverse function since every output has exactly one input. So if you look at the arrows, if you follow them back, each arrow only goes to one input. So we know the inverse function exists since every input has exactly every output has one input. Sorry about that. One input. There we go. Okay, so you know it's a function if each input has one output. You know it's an inverse function exists if every output has one input. Okay. Now, this is the key here. This is kind of where we were leading up to with all of this. When both of these exist, when the function and, that's the key there, inverse function, both exist, the function is called one-to-one. Okay, so we described one-to-one functions before, but this is kind of the key there. When you have a function and an inverse, then they both exist. All right, so one more additional note here. See me write f inverse of x means inverse function. Okay, it does not mean f to the power of -1. Okay, so you won't treat it as an exponent. Okay, so f inverse of x does not equal 1 over f of x. Okay, so similarly, if we had 3 to the -1 power, that would be 1/3. These are not the same. Okay, that is an exponent, where that is not an exponent. Not an exponent, just a notation. Okay, so you would not treat these two the same. All right, so I just wanted to kind of clear that up just in case anyone was confused by that. Prevent any future mistakes, hopefully. All right, so if you're still writing, by all means, feel free to press pause. But we're going to go ahead and go to our next example. Alrighty, so let's say, for example, we want to determine if f of x equals x squared, is 1 to 1. All right. So let's say if we know that f of x equals x squared. Okay, so what if we let x equals 1? Well, let's say x equals 2. I want to pick something as cut and dry as 1. Let's say x equals 2. Okay, so that means that f of 2, which is 2 squared, equals 4. So we know that f of 2 equals 4. And remember, these are just random picks. You don't have to always pick x equals 2. And let's say if we have x equals negative 2. Okay, so that means f of negative 2 is just negative 2 squared, which is also 4. Okay, so that gives us f of negative 2 equals 4. Now, if we wanted to find the inverse, that means that we would have to apply f inverse to both sides. F inverse to both sides. Okay, now the inverse and the function would cancel each other out, and I'll show you what I mean by that. F of 2 equals 4, that's what we're starting with. Now we're going to apply f inverse to both sides. So we have f inverse of the left side, which is f of 2, equals the f inverse of the right side. So you have f inverse of 4. Now this function and the inverse cancels each other out. So I'm just going to go ahead and switch these up just to have an inverse on the left. So you have f inverse of 4 equals 2 once those two cancel out. Okay, so what about f of negative 2 equals 4? Again, we're going to apply f inverse to both sides. If we apply f inverse to the left, you have f inverse of f of negative 2 equals f inverse of 4. Okay, so again, the function and the inverse cancels out. So f inverse of 4 is equal to negative 2. Okay, so that kind of gives it away there, because since f inverse, let me bring that down a little bit so it's not all bunched up. There we go, give it a little more space. Since f inverse of 4 equals 2, and f inverse of 4 equals negative 2, f of x equals x squared is not 1 to 1. Okay, and if you remember, we already verified that in previous videos, looking at the horizontal line test. Okay, so f of x equals x squared, it kind of looks like that. If you draw a horizontal line, it crosses that graph more than once. Okay, so if you remember, f of x equals x squared fails the horizontal line test. So that also showed it wasn't one-to-one. Okay. So really, both of these show the same thing for f of x equals x squared. They're just two different methods of showing that f of x equals x squared is not a one-to-one function. It is a function because it passes the vertical line test. It's just not a one-to-one function because it fails the horizontal line test. All right? Okay, so if you're still writing, please feel free to press pause. We're going to go ahead and go to our next example. All right, so let's say, for example, determine if f of x equals x to the third power is one-to-one. All right, so again, we're just going to pick random values. Let's say if we let x equals 1, so that means f of 1, which is 1 to the third power, is just 1. Let x equals 2, that means f of 2, which is 2 to the third power, equals 8. Or x equals 3, so f of 3, which is 3 to the third power, is 27, and if you want, you can keep on going and going and going and going and going. You can do f of 4, which is 4 to the third power, which is 64, and keep going from there. But we're going to stop there. And let's say if we want to do just a few negative numbers, say x equals negative 1. So f of negative 1 equals negative 1 to the third power, which is negative 1. Say x equals negative 2. So f of negative 2, which is negative 2 to the third power, which is negative 8. And we'll do one more. F of negative 3, which is negative 3 to the third power, which is negative 27. And if you wanted, you could keep on going and going and going. All right, so now we see that every x value has only one y value. So x equals 1, y equals 1. X equals 2, y equals 8. X equals 3, y equals 27. You don't have a different value for x equals 3. Same thing here. X equals negative 1, y equals negative 1. X equals negative 1 will not have a different value. So we know it's a function because every x has exactly one y. Now, we're going to find the inverse. Okay, to both sides. Okay, so we're going to do f of 1 and f of negative 1. So we know f of 1 equals 1. So we apply f inverse. So f inverse of f of 1 equals f inverse of 1. So we just applied f inverse to both sides of the equal sign. These two are going to cancel each other out. So we know f inverse of 1 equals 1. Okay, so what if we try f of negative 1? F of negative 1 equals negative 1. Applying f inverse to both sides. So f inverse of f of negative 1 equals f inverse of negative 1. Those two cancel each other out. So we know f inverse of negative 1 equals negative 1. Okay, so how about f of 2? We know that equals 8. F inverse of f of 2 equals f inverse of 8. Remember, those two cancel each other out. So we have f inverse of 8 equals 2. And we can keep on going and going and going if we wanted to. But one thing we want to notice is that every x has one y, and every y has one x. So the inverse exists for each value of x. Okay, there's only one value. F inverse of 8 doesn't have a different x value here. Okay, so since the inverse and the function both exist, since I'll say the function, since the function and inverse exists for each value of x. Okay. Now, the thing is, and they are unique. Okay. So that means that f of negative 1 only has one value. You can't plug in f of negative 1 a second time and get a different value. So that means we know that f of x equals x to the third is 1 to 1. And if you graphed it and decide to do the horizontal line test, you would see that it would pass. Well, we did it in the example in previous videos, so you can always go back and look at those. All right, so if you're still writing, please feel free to press pause. I'm going to go ahead and move on. Oops. Okay, so now we're going to look at the steps for finding the inverse of a function. Okay, so if you're given a function, we're going to be able to find the actual inverse of that function. Okay, so step 1, replace f of x with y. That's only if necessary. Okay, that just means that if it's already a y, you can skip step 1. Okay, now you're going to interchange your x and y variables. Okay, so in other words, your x's become y. I put the line in my s so you won't think it's a 5 or anything. Become y's, and your y's, will become x. Okay, then your third step is you're going to solve for that new y. Then you're going to replace y with f inverse of x. Okay, so now we're going to look at, just before we go to a few examples, I'm going to give you the actual definition of an inverse function. Okay, I gave you kind of a simplified definition of it earlier, but this is kind of the actual definition. Okay, so if you have some function f is 1-to-1 with the ordered pair you have x comma y, then the inverse function which we're going to denote by f inverse, is 1-to-1 with the ordered pair yx. Okay, so there are various ways you can define an inverse function. And I just wanted to kind of expand on the definition. All right, so if you are still writing, please feel free to press pause. But we're going to go ahead and go to the next example. Okay, so let's say, for example, determine whether each function is 1-to-1. If so, find the inverse of the function. Okay. So A, let's say that f of x equals 4x plus 2. And for B, let's go with an old standby of f of x equals x to the third, where we know it's a 1-to-1 function, but we have to find the inverse function. That's the difference. We know it's 1-to-1, but now we have to identify the inverse of it, what the inverse function would look like. All right, so I'm going to go ahead and just kind of draw a line down the middle there. Okay, so to solve A, we have f of x equals 4x plus 2. Okay, so remember your first step. You're going to replace f of x with y. You have y equals 4x plus 2. Okay, now you have your second step. You're going to switch x and y. So that means instead of y equals 4x plus 2, your y's are going to become x and your x will become y. So you have x equals 4y plus 2. Okay, then you have your third step. We now solve for y once we switch it. Okay, so we subtract 2 from both sides. Well, let me say x equals 4y plus 2. We subtract 2 from both sides. That gives us x minus 2 equals 4y. Divide both sides by 4. These two cancel out. I'm just going to switch that over here. So y equals x minus 2 over 4. Then your fourth step, replace that y with f inverse. So f inverse of x equals x minus 2 over 4. Okay, and this is the inverse function of f of x equals 4x plus 2. All right, so go ahead and go with B. Bring that down a little bit. Okay, so f of x equals x to the third power. Actually, what I want you to do is following these same 4 steps over here, I want you to find the inverse function of f of x equals x to the third. Okay, so go ahead and press pause and see if you can solve that one on your own. All right, so assuming you have already pressed pause and worked that one out, we're going to go ahead and verify your answer. So remember, first, you have y equals x to the third power. Then you have your second step, where you switch your x and y's. So that gives you x equals y to the third power. You have the third step, where you solve for y. So if you take the cube root of both sides, so x equals y to the third power, take the cube root of both sides. These two will cancel each other out. So you have y equals the cube root of x. Where you have your fourth step, change that y to f inverse of x equals cube root of x. Okay, so this is the inverse function of f of x equals x to the third power. Move that up a little. There we go. And those are your two inverse functions. All right. So if you're still writing, please feel free to press pause. But we're going to go ahead and move on to the next thing we will be covering, which is the composite of inverse functions. Okay, so we kind of jumped to this earlier, but I'm going to give you the actual definition of it. For any one-to-one function, we have f and f inverse, our function and our inverse function. then f of f inverse of x, so the composite of f and f inverse of x equals x, and the composite of f inverse and f of x equals x. All right, so we're going to use the example we had previously to show that this is true, or as an example that this is true. Okay, so what if we wanted to verify that f of x equals 4x plus 2 and f inverse of x equals x minus 2 over 4 are inverses of each other. Okay. Well, that means if we take the composite of f and f inverse, it should all cancel down to where our final answer would be just x. Okay, so let's say we want f of f inverse of x. Okay. We go ahead and just rewrite that. That's really just equal to f of f inverse of x. Same thing, just written differently. Okay, so we know f inverse of x is just x minus 2 over 4. So that's just f of x minus 2 over 4. Okay, so we know our f of x is 4x plus 2. So f of x minus 2 over 4, we're just going to replace x with x minus 2 over 4. So that's actually going to equal 4 times x minus 2 over 4 plus 2. Since that's our f of x. And we replace it. So if we go ahead and simplify this, these 4's cancel each other out. So that leaves us with x minus 2 plus 2, where these 2 cancel out, which is just x. Okay. So how about if we flip it the other way around? F inverse of f. Okay, so if we have f inverse f of x. Okay. Just like we did up here, we're just going to rewrite it. That's f inverse of f of x. Just a composite. Okay, so we know that f of x is equal to 4x plus 2. So that's f inverse of 4x plus 2. Okay, so we know that f inverse is x minus 2 over 4. So f inverse of 4x minus 2, we're just going to replace x with 4x minus 2 in that one. So that's going to equal 4x minus 2 over 4. All right, so since this is positive, we can go ahead and drop the parentheses. So that's just 4x minus 2 minus 2. Oh, 4x plus 2, sorry about that. I had to catch that one there. All over 4. These 2 cancel each other out. This leaves you with 4x over 4, which is just x once those 2 cancel out. So you can see here that if you get the composite of a function and its inverse, you should be left with just the variable x. Okay, so that's one way you can always double check if you are trying to come up with the inverse function and you want to double check to make sure you did it correctly. If you do this, that's your way of double checking your answer. All right. So if you are still writing, please feel free to press pause. We're going to do one more example. All right, and this one is a problem that I printed up already. Okay, so what if you have a function g of x, which is this function here, is given in the figure below. Find g of 3 and g inverse of 3. All right, so what I want you to do, press pause. I want you to look at this one and see if you can solve this one on your own. Okay, go ahead and press pause. All right, so assuming you've already pressed pause and you've worked this one out, let's go ahead and verify your answer. Okay, so let's say if we wanted to find g of 3. Okay, really all that's saying is what is the, you can say y value, but it's really g of x, so we'll just kind of simplify it. What is the y value when x is equal to 3? Okay, so that's really all this one is saying. Okay, so when x is equal to 3, your y value is 1. Okay, so we can see here that g of 3 is equal to 1. Okay, now we're going to look at the inverse. And to find the inverse, you have to kind of think of it a different way. Okay, so to find g inverse of 3, this one, remember, is a little bit different. This says for g of 3, you want to know what the y value is when x is equal to 3. For g inverse of 3, you want to find the value of x when y is equal to 3. Or what is the value? There we go. That's a little bit clearer. What is the value of x when y is equal to 3? So you see here, it's a little bit of a switcheroo. Okay. So y is equal to 3 here. When y is equal to 3, it hits the graph at x equals 5. Okay, so that means that g inverse of 3 is equal to 5. Okay, so that was just a way to kind of visualize it so you'll see that it really is just kind of a switcheroo. Okay, to find just g of 3, you want to know what's the value of y when x is equal to 3. To find your g inverse, what's the value of x when y is equal to 3. Okay, so that's really all there is to it. Okay, with a little bit of practice, you should be okay. That's the end of this one. Hopefully it made sense, and I will see you on the next video.